I am Jarek Kurnitski, so professor from Tallinn University of Technology, also being a adjunct professor at Aalto University in Finland. So actually I have quite a long research track and working track in Finland, working more than 20 years in Finland in research and later on also in research funding duties. So my latest post was in Sitra, what is the Finnish Innovation Fund, where I was responsible to conduct quite a large energy program. And 2012 I moved back to academic sector, starting as a full professor at Tallinn, and then I also was invited to Aalto University. So now I try to give some overview about Estonian achievements in energy efficiency related to new buildings and also to renovation. So I will give you some overview about Estonian energy performance requirements. Estonia actually was the second country after Denmark launching nearly zero energy building requirements in the regulation. And there is also something for major renovations, but this is basically not driving the market. Renovation grant scheme, Gredex one, is very well known and really a success story in Estonia, so this is driving really a renovation market. And most likely I cannot give many examples about our research topics because of very limited time. But briefly in Estonia, the history starts from 2007 when the first primary energy-based regulation was prepared. Estonia likely was the first country in Europe conducting cost-optimal calculations. We also published this as a scientific paper, and it's the most cited paper I ever have been published. And when these have already once updated, so new ones from January 2014, and actually these new requirements are called as cost-optimal because they follow these cost-optimal calculation principles, which is basically 30 years life cycle calculation for residential buildings with net present value method. How it looks, Estonian nZEB with A-class energy performance certificate is defined as a nearly zero. Indeed, its requirements are published, but it's not mandatory yet. We are following the same time schedule as everywhere else in EU. And this is an example of information sheet included into that energy performance certificate. You can see that this is actually for Class A apartment building, one of the very first ones being built in Estonia. So this is actually not very old, launched April this year, and the building is under construction. And it really will be actually, this one will be the second apartment building which is nearly zero energy in Estonia. When the Estonian system is quite advanced, we are using energy frame which enables full utilization of on-site renewable energy production, and also exported energy is enabled. So there is really delivered energies and exported energies, and on-site renewable energy generation is included. So it follows European REFA nZEB definition and system boundaries. And what's very special in Estonia, we also have included lighting, appliances, plug loads. So everything it's some sort of all-inclusive energy frame, so that you can expect that the calculated and simulated values are quite the same as the measured values. And this is not the case in many European countries. So this is the one launched by Verifa for the European implementation as some sort of technical support for the directive, and has been very well followed in Estonia and, for example, in Finland and in some other European countries, and very recently also followed by US Department of Energy. They published also very similar recommendation. So in Estonian regulation, compliance assessment is based on commercial building simulation tools. There is no official fixed calculation method, but it is just required in the regulation that you need to have a dynamic building simulation for most of the buildings. Only exceptions are residential buildings which do not have cooling systems, but for all non-residential it needs to be a dynamic building simulation, and when it's just specified that the simulation tools needs to be validated with relevant methodologies. And there are also some requirements defined for the simulation tools which can be used. So that's the way how very small country as Estonia can really tackle such issues, because a lot of effort has been used worldwide to develop building simulation tools, and they are very well available in the market, and even not very expensive ones. And basically there is no need for the government to put funding to develop a national calculation tool. So this has actually quite well worked in Estonia, being based such commercial tools. And another advanced feature we have is that there is an overheating requirement for buildings, which is especially actual in residential buildings having no cooling systems. And when you need to run dynamic temperature simulation in critical rooms to comply with summer temperature requirements, which are in residential buildings 27 degrees, and excess hours are defined as 150 Kelvin degrees are accepted excess, and this needs to be proved by the dynamic temperature simulation. Only exception is for detached houses, where you can use tabulated values and to prove that it's enough solar protection, window sizes are not too large, and it's enough window airing for the night ventilated cooling to keep temperatures under control. So, starting from minimum requirements we have today in force. So these are basically Class C requirements in Estonia, and it's not very easy to compare between different countries, but with some sort of a recalculation it is possible. This is for detached houses, and you can see very common oil or gas boiler heating, and Estonia, Finland, Sweden, Norway pretty on the same level, and Denmark is known as a world-leading country in energy efficiency and renewable energy, so they have a bit more strict requirements. It's quite interesting when we look what happens with electrical heating, because of different primary energy factors, very different energy production. So these values are not so consistent, and for example in Norway they do not distinguish between heat and electricity in the building regulation calculation, and there is no difference. In our countries it's quite a lot of difference. Then the similar comparison for apartment buildings, which are these blue ones here, and now it's considered that district heating. Estonia is also one of these district heating countries where all major cities have a district heating networks, and in similar fashion like, for example, in Finland or Sweden. And it's quite amazing that in these Nordic countries, the requirements are very close to each other when we speak about apartment buildings. So exactly the quality requirement for the energy performance of new apartment buildings is almost the same. And Denmark is once again a leading one. When we go to office buildings, which are there is a bit more fluctuation and different reasons, especially for Finland. It's some historic reasons in the Finnish code, but this will be soon fixed with much more strict requirements. But this is we have today, and it's very difficult to compare what are nearly zero energy building requirements. I have ongoing couple of master theses working with this kind of a comparison, and it's really a mesh, and this data is not yet available, not easy to compare. So in Estonia we have specified requirements for 9 building categories, and also for applying for new buildings and for major renovation. So primary energy factors you can see here. We are using for electricity 2, fossil fuels 1, district heating 0.9, and renewable fuels 0.75. So, and there are some examples. For example, in apartment buildings, nZEB is 100, and requirement we're having today is 150. So the values here in parentheses are without lighting and appliances. So, because in many European countries they are operating not with full values, but plug loads, lighting, appliances not included when it's more comparable to these countries. So, and it really depends what is included in that primary energy indicator. And this is a full set of these 9 building categories showing that really the energy use intensity in the buildings and also operation times are quite different, and also requirements when numeric values have a large variation. So when coming to the existing building stock and to the renovations, as a directive requires, also Estonia has minimum requirements for major renovation. It's actually energy performance certificate class D, but this is not driving the market, because very seldom renovation is classified as a major renovation. It is always possible to do 2 renovations, and then they are not major ones. So how the market can be driven, it is just by some sort of incentives, and the Estonian CREDEX scheme is based on renovation grants, which is basically direct financial support for apartment buildings renovations. And this is really one of the European success stories, already been in use for first 5 years period, and now the second 5 years period has been started in Estonia. And it is built so that energy saving is not required as percentage, but you need to achieve energy performance certificate class C in the case of highest financial support of 40%, and class D is enough for the 25% of the support. So the system first was run for 2010 to 2014, and now it's second term, and EU structural funds are used to fund this system. This is one example from the first period. So a major renovation with investment cost around 180 euros per square meter, and quite a big project. So in this example, it's a full insulation of a building, as it is a common. When also the windows were moved to the insulation layer to avoid thermal breaches. Heating system, in this case, district heating remained, and it was supported by exhaust air heat pump to have a heat recovery from the exhaust air. So it's basically mechanical extract ventilation, and ventilation system included ventilation radiators to heat up and to filter intake air, and this is one of the most common systems, also used quite much in today's renovations. But indeed, today we can do even better. And why these renovation grants are applied, this is also results from our one research project. So we have been able to quantify that tax return to the government is actually as high as 32% from a total cost of the renovation. And indeed, this job creation is not bad either. 18 jobs created by €1 million renovation cost. And we really can claim that this kind of direct financial support for the renovation is a budget neutral or even positive activity for the government based on these research what has been based on real renovation projects and the cost structure of the real renovation projects. So this is well justified, and that was the reason the highest grant was even increased to 40%. So basically, these 25 and 40 are the most common ones, and actually most of applications have been for these maximum 40% financial support, because it's more beneficial for the building owners or these housing associations who are applying these grants. So the breakdown of a typical renovation requirement, it's a primary energy 150 kilowatt hours per square meter, but when you check from energy need, you can see that there is not much left for the space heating when it's indeed needed for ventilation heating. The domestic hot water value is a regulated value, so need is fixed, but how much you use energy to heat this coming out from the tap indeed depends on the system. When it's for the fans and pumps, lighting and appliances values are fixed, and then total would be around 100. When from the need, when you move to the delivered energy, taking into account all the system losses, conversions, what happens meanwhile, and when primary energy factors are applied. In the case of a gas boiler, used in this example, primary energy factor is 1, and for the electricity it's 2, and then it ends up to this 150. So this is the maximum what it would be. In the case of a district heating, primary energy factor would be 0.9, so it's a bit more easier to achieve this requirement with district heating compared to gas heating. Already somebody here, first presentation was about the importance of the ventilation, and we really, that's also an Estonian experience, that in renovation there are 3 important issues: ventilation, ventilation, ventilation. That's really it. And in the new requirements, we have specified how many liters per second per room you really need to have a supply or intake air or extract air in the wet rooms like toilets, kitchens, bathrooms. And in this 25% renovation grant, heat recovery is not required, but indeed you need to achieve energy performance with these defined ventilation rates. In some buildings it can be quite challenging, and it would be good to have a heat recovery, but basically it's not required. For the case of a 40% renovation grant, heat recovery is required. So it can be either mechanical supply and exhaust ventilation with heat recovery, or exhaust air heat pump with ventilation radiators. So basically these 2 systems are accepted, and other ones are not accepted. And designers really need to do this airflow, so a ventilation calculation, and when it is also required that it will be measured. And measurement protocols are required before handing over and paying the last part of that financial support. And this really changed the market. Now the ventilation systems have been installed, they are balanced, they are measured, and the airflow rates have been achieved. So no more any more mold and moisture problems and problems with not sufficient ventilation seems working quite well. And there are also insulation requirements are quite tight, and in the case of 40% grant, it is also for the thermal bridges, basically meaning that you will need to move the windows from their original locations to inside the insulation layer. So natural ventilation is not anymore accepted, no way to go if somebody wants to get these renovation grants, not possible. These kind of room ventilation heat recovery units are not also anymore accepted because of very bad experience from the previous period, and also because they do not fulfill the main principle of residential ventilation, where you need supply air to the bedrooms and living rooms, and you need to have extracts from bedrooms like toilets, kitchens, bathrooms, but these units will do it within the same room. And when additional exhaust will be needed from bedrooms, and this would destroy the heat recovery, even in the case of very well assembled units. So ventilation solutions in use are mechanical exhaust with exhaust air heat pump and ventilation radiator. So this is one basic solution what is accepted and used in quite a wide scale. And in this case it's very important that these ventilation radiators as a commercial products are used. So it means that outdoor air is heated up in the radiator, and there is also an air filter, supply air filter. In such a way, this preheated air enters to the room, and the temperature is almost equal to the room temperature. So in such a case, there should not be any draft problems, and it is also filtered air, which is important in the city environment. So, as I told, we can do even better, and now it seems that mechanical supply and extract heat recovery ventilation is really possible to apply in renovation. So it applies only for a couple of countries, I would say for Estonia, then for Sweden, and maybe somehow also in Finland, where these kind of solutions have been used. And indeed, it's tremendous work to get these through, and it seems that in Estonia we have succeeded, and it has been mainly ductwork installations into the facade. So because there are 20-25 centimeters external insulation, there is quite a plenty room for the ductwork, and in such a case there is no need to go into the apartments. And all construction work inside the apartments are very complicated in these kind of renovations. So this ventilation works can be kept on the roof of the building and in the facade, and almost nothing in apartments. And this seems to be a solution for apartment buildings. So, and now they have also found that these plastic and not some sort of oval ductworks are more flexible and more easy to install, and this really seems to be very economic installation of the ventilation and air handling units on the top of the roof, and then these will be all in the insulation layer, and this is how the building looks after the renovation. So it has a mechanical supply and exhaust ventilation with heat recovery. In most cases, they can utilize existing stacks for extract air, but in some cases also extract ductwork has been installed to a building envelope because they see that it is difficult to comply ventilation flow rate requirements with the old stacks, which are not airtight and could be very leaky. So it really depends on the building. But in any case, a supply air ductwork installed to a building facade. So this is how it goes in Estonia. And just to conclude my presentation, indeed there has been a lot of research effort to make this possible in Estonian renovation. We have had quite many doctoral theses in the renovation of apartment buildings. Regarding the new building research, we have, this is our facility 3 years old for nearly zero energy building test bed, which is quite unique, I would say, also in European scale. So this is for the solutions applied in new buildings, both for HVAC systems like heating ventilation systems, renewable energy systems, and also for a building envelope. So it's a combined facility of a building physics, HVAC, and indoor climate. And this is the first nZEB office building in Estonia, which was completed actually last year. So I think I have used all my time. Thank you very much. I have very many slides about our research, but these slides will be available, and I will stop here.